Aerial today. All right. So first up, okay, let's review. So these first two warm-up problems are from 10.1 and 10.2. This has nothing to do with what we're working on, just a review, because it's been so long since I've seen you. All right, first problem is actually from 10.1, just to give you a reference. So you look at it, yeah, it's a circle problem, but technically you have a right triangle. So it's really a Pythagorean theorem problem. A squared plus b squared equals c squared, or I always just think of it side squared, I'm going to start with 9, plus my other side squared r. Now here's where it gets fun. Your hypotenuse. We all know what the hypotenuse is, the longest side. Clearly it's this side here. It's the 6 and the r combined. You have to add those together and then square it. So there's the geometry setup. Now it's a little tricky on the algebra side of it. I know we all know 9 squared. Here is, and I shouldn't really say tricky part, but what you have to remember from Algebra 1, you have to write this binomial down twice and then FOIL it all the way out or distribute it all the way together. So it's a lot of algebra work. The geometry part was easy. So I'm going to do 6 and 6, 6 and r and 6, r and r. I need longer arms. Okay, so you've got a lot of stuff here. We've got a lot of terms, but you have an r squared on either side, so they're going to cancel out. I'm just going to get rid of those. So I've got 81 on the left. I'm going to add my 6r and 6r together on the right. I'm going to make it 12r. Yes, I'm running out of room. Okay, now super easy. Subtract 36, divide off the 12. No big deal. So we're going to do, I'm going to put it up there on the side because I'm running out of room. 81 minus 36, of course, 45. I'm going to sneak it under here. When you divide by 12, you do not get a nice whole number. You're going to get a decimal, which is fine. You end up with 3.75.
What's a nice decimal?
That's not a bad decimal, right? Could be worse, could be worse. All right, so just a review of 10.1 is what this problem is. And again, the key is that hypotenuse, the 6 plus r. Now, number 2 is a little review problem from 10.2. Couple questions for you. First off, how many degrees in a full circle? 360. So how many in a half circle? 180. So you've got some diameters in here. Remember, diameter goes through the middle. So we've got some diameters that split this into 2 half circles. So I'm going to look at this diameter here. So I've got the left side. So I'm going to add these 2 pieces that make up the left half of the circle, and I'm going to add them to 180. So I'm going to do 8x plus 9. I'm going to add the 115, and that makes half a circle, 180. Super easy to solve now. Let's add our 9 and 115. So 124. I can't write on top. My hand kind of hurts today. There we go. All right, so subtract your 124 and then divide off your 8. I know you can handle it from there. I'm going to give you a second to punch it in your old calculator. Final answer is 7. Perfect. Okay. Now, one thing too, and you've seen this before in other chapters, this is very typical. Anything we have covered, and you're going to see it today, is fair game, even in today's section. So even though I'm not necessarily on a semicircle section today, there might be some things we have to add to 180. You might still have a full circle that you have to add to 360. All of that previous knowledge and skills are in play today, just for the record. So today we're going to talk about what's an inscribed angle. Sounds super fancy, it really isn't. And then we're going to talk about polygons. Polygons, enclosed figures, enclosed in a circle. So, as always, let's do the vocabulary. So a few things you got to fill in on your note sheet on the blanks, of course. An inscribed angle is an angle whose vertex is on the circle. So here's where I wish we had color copy machines for you guys. So you can see my blue angle on the screen. The vertex is on the edge of the circle. That's what makes it an inscribed angle. Now, the other endpoints, of course, define what we call the intercepted arc. Now let's talk about that. What's the intercepted arc? So you can see in my very lovely picture here, I wish you had color pictures. It's the red. What's in between the angle. So there's going to be a relationship between your intercepted arc and the angle. Okay, so let's also, you have to fill in inside. So get all your blanks filled in there on your notes. Now, I'm going to show you, and it's super easy, the calculations, but, a little common sense here. Because sometimes kids are like, oh, I can't remember, should this part be bigger, should this part be smaller, how does this play out? Well, look at your picture, a little common sense. Your angle is smaller than the arc. This arc should always be bigger than the angle. I know I always tell you don't assume anything from the picture, but you can this time. So if you're always like, oh gosh, I can't remember which way do I do this? Do I do this or that? Your angle should always be smaller than the arc. That's how the picture looks too. So how do you get the angle? It's half the arc. Let me give you a second to write that down. We'll look at the pictures here in a minute. But fill that in. The inscribed angle equals half the intercepted arc. So today, I kind of already previewed this. You're either cutting things in half, easy, or we might be doubling them, the opposite of a half. And here's how you know. For instance, let's say I tell you the arc is 70. I'm going to make it easy. I know the angle should be smaller. It's half as much, 35. That's legit like a third of your homework today is doing this. Or, and you'll see them, we'll do some. I might get super fancy today and be like, okay, I'm going to tell you your angle is 23. So what's the arc? 46. You double it. So you're always, of course, in that ratio of the angle is smaller, half as much as the arc. So either halving stuff today or doubling stuff today, depending on which piece I give you, the angle or the arc. That's as crazy as it gets. All right, the pictures on the bottom here on the front of your notes, this is no big deal. This is just showing you, because I'm dropping things, this is just showing you how some of the different angles, inscribed angles could look. So you could have your inscribed angle actually hit a diameter. Process is still the same, angle. You could have it make an obtuse angle. You could have a little acute angle. Doesn't matter. You're always still in the ratio of the angle is half the intercepted arc. Just some different ways they might look today. All right, let's do it. Find the indicated measure. I'll give you a second to flip it. So remember, we're either halving or doubling. That's the big math calculation of the day, my friends. So they want angle T. So I'm going to highlight it in red, angle T. So that's what we're trying to find. So you know the intercepted arc is 48. Common sense, look at your picture, the angle should be smaller. So we're going to half it. Half of 48, 24. That's too easy. Okay, let's do the next one. I'm going to do that one in green. Arc QR. Arc QR. Okay, so this time I'm going to have to do a little bit of work here, okay? Because remember I kind of said this is now a free-for-all. You can use any of your information. I'm like, oh gosh, I need arc QR. There's not an angle that's inscribing QR, so I'm not going to give up, but I am going to take a look at this. Clearly they give you this 50, so I'm thinking we probably got to think about or do something with the 50. It's not just on there, you know, for fun. There's probably a meaning to it. So if this angle's 50, I know it's inscribed arc, I would double. So that's going to be 100. Now you should be able to figure out the green, what we actually need, minor arc QR, because you have a semicircle. A semicircle adds up to what? 180. So our green piece, we're going to need 80 more. So still easy, but again, some of your previous knowledge you might have to use. You might have a semicircle, you might have a full circle, etc. All right, let's take a look at this guy. Find the measure of arc RS. That's what they want. Now, super easy. This time we do have the inscribed angle for arc RS. I'm going to do it in red here. So we've got the 31. So the question is, to get the arc, do I half 31 or double 31? Double. It needs to be bigger. So 62 degrees, there's the answer for that. I'm just going to write it over here so it looks pretty. Or you can just label yours on the picture. I don't care. Okay. Next, it wants angle. S I'm going to do this one in green. T, R. So we need this angle. Well, notice it intercepts the same arc. So if the arc is 62, now the angle needs to be smaller, so I'm going to half it. So 31. So I'm going to list that. Okay. And, this is not a trick question, it also asks you, what do you notice about angle STR and angle RUS? They're the same. They're both 31. I'm going to say the angles are congruent. Which I knew was going to happen. This is leading you to the next theorem. I knew that was going to happen because look at my intercepted arcs. My red dash, my green dash, it's the same arc. If the angles intercept the same arc, they're going to end up being the same. Kind of common sense if you ask me. So that's this next little theorem here that's on here that we're going to fill in. If two inscribed angles, so fill that in, of a circle intercept the same arc, then the angles are congruent. Let me give you a minute to fill in the blanks. We'll look at the picture, but we really just did it. So if you look at your angles in the picture, just to highlight them, I'm going to do this kind of top one here, this guy in red. So you can see it's intercepted arc A to B. And then if you look at angle C here, I'm going to do that one in green, it intercepts the same arc, just like the last problem. So the angles are congruent. I know, it's very exciting. Common sense. Okay. Name two pairs of angles that are congruent in the figure. So clearly what we're looking for is they have the same intercepted arc. So that's what we're really looking for. Unfortunately, no easy, quick way to do this. We have 8 pairs of angles here. 8 pairs of them. We have to figure out which ones are going to be congruent. I'm just going to start at A and pray the answer is not D. Okay, so let's start at A. Angle JKM. So JKM. So here's its intercepted arc. And then angle KJL. Let me down into it. KJL. Do those intercept the same arc? They sure don't. So I know it's not A. I'm not even going to test the bottom set because the first ones are congruent, so it's clearly not that. Do we think it's B or should we guess another one? Jacob said C. Let's try C. JKM. JKM. Got it. And then the other one, I'm going to do it in green. JLM. Oh. Huh. Those intercept the same arc, so I like that pair. That's a winner. Let's check the second pair. Jacob might just be onto something. He might be a good guesser here. So I'm going to do the bottom pair. KJL. So that's this one. Okay, let's do this guy in black. KML. Do those intercept the same arc? Sure do. Good guess, Jacob. Way to save us some work. I was like, please don't be D. So easy, yeah. I mean, they intercept the same arc, they're the same. It's easy. It's just obnoxious because you have all those different choices you have to sort through and figure it out. All right, here we go. Now, here is where you might either, this is where I wish I had a color copy machine, want like a highlighter or a red pen even, because notice the directions. Find the measure of the red arc or angle. Yours are clearly not in red, people, okay, because we don't have color copy machines here. So you might want to either bold in what you're trying to find, or if you have a highlighter or a different color pen, because otherwise you're going to look at this example and be like, say what now? What am I supposed to find? So clearly they want the red here. And again, I don't care if you actually do it in red, if you just kind of bold it in with your pencil so you know what the heck you're finding. Just so it's clear, so you know what you're doing. All right, let's do A. I like it. So you know the intercepted arc is 90. So do you half 90 or double 90? Half, so 45. The angle should always be smaller than the arc. Okay, you've got the angle's 38, so what's the arc? 76. Again, this is like half the homework problems. This is easy. Okay, this one. Now, your red arc here, our intercepted arc is this guy. You can get that with no work. Because if you look at this 72, do that in green, the 72 intercepts the same arc. So if they intercept the same arc, the angles, remember, congruent. So this one's also 72. You don't even have to overthink it. Okay, too easy. Any questions on those? All right, let's get into this polygon part of the lesson. Easy, but as always, we got some vocab to go through. Polygon, now that's just an enclosed figure, a square, a rectangle, a triangle. Here you can see a triangle. Polygon placed inside a circle, inside the circle. So each vertex, remember the vertex is the corners. A triangle has 3 vertices. A quadrilateral, 4 sides, has 4 vertices. Just FYI, so you know. Now, circumscribed polygon, the circle that contains the vertices. That's what they call the circle, the circumscribed circle. So the red circle gets a little fancy name. I know, super exciting. Now, what does that mean for us? Not a whole lot's going to change here. So notice this time we technically have an inscribed polygon because you have a triangle, okay, inside the circle. Now, but that really doesn't change anything for us. Find the value of x. So we're looking at this inscribed angle. So we know the angle is half the intercepted arc. So the question is, we need to know this, what's going to be this arc? It's how much of the circle? Half the circle. It's a semicircle. Half a circle, of course, 180. So I used my previous knowledge to get that 180, the half the circle, okay? Now I'm ready to figure this out. So the angle, the 3x, is half the arc. So I'm going to write it out, but some of you can probably just solve that in your head. The angle is half the arc. So 3x has to equal 90. So I'm like, okay, half of 180, 90. And clearly some of you can just figure out what x would be in your head. I'm going to do the math, divide by 3, 30. So now you might just have a little more algebra to do. They got fancy and put a 3 on there, so we had to divide it off. Not that that's really that exciting, but just one other little extra stuff to do. Now, inscribed quadrilateral. Quadrilateral, 4 sides, of course. So it can be inscribed in a circle if and only if. So you're going to fill that in on the blank. Its opposite angles are supplementary. Good vocab word there. Let me give you a minute to fill in your blanks. Now remember, it's on the screen, but you know it. Supplementary adds up to 180 degrees. So let's talk about opposite angles. So angle E is opposite G. So those two should total up to 180. And clearly your other opposite angles, F and D. That pair should also total up to 180, just for the record. And that's what that's all saying down there. I just circled them in little fancy colors for you. Okay, super easy. I don't even think we'll need a calculator. Doesn't matter which pair of opposite angles you pick. I'm just going to pick a pair. I'm going to start with Q. Opposite angle, S. So these have to total to 180. Clearly X needs to be how much? Got it. I could do this all day. Okay, other pair of opposite angles, P and R. So those need to add up to 180. So if you have 75, how much more gets you to 180? 105. And I don't care on your homework, of course, if you just write them in the picture, like I did. A lot of times I just write it in the picture. Or if you actually know x equals y equals. As long as you have the 100 and the 105, I'm happy. Okay, same thing. Doesn't matter which pair opposite angles we start with. I'm going to pick a pair. I'm going to do L and J. So those should add up to 180. Now I'm going to do a little more algebra on this one. Because 2A plus 2A, 4A, should total up to 180. Now here you might need your calculator. We're going to clearly divide off 4. 180 divided by 4 is 45. Probably could have done that in your head. All right, opposite pair, K and M. So 4B and 2B, 6B, should add up to 180. So B, you don't need your calculator for that. B is going to be what? 30. Too easy. Okay, so that was kind of the second part of the title. Remember, the title of this lesson was Inscribed Angles and Polygons. This is the polygon stuff that adds to 180, those opposite angles. So the last thing we're going to do, this is a free-for-all, okay? So this could be anything. You might have to use half a circle. You might need to use a full circle. You might have an inscribed angles. We're just going to see what we have. A little more algebra on these. So, of course, number one, inscribed angle. The vertex is on the edge of the circle. So we can handle that. We know that. The angle should equal half the intercepted arc. And our arc, of course, is this weirdo 39x minus 3. So still the same calculations, but a little more algebra heavy. Now here you have a choice. You'll get the same thing. Of course, you could distribute the half through. Half of 39, half of 3. That's going to be very fractioning. I'm not sure fractioning is a word, but you're going to have a lot of fractions. If you don't want to deal with that, you can get rid of the half just by multiplying each side by 2. I don't care which way you do it, you'll get the same thing. So 2 times 57, 2 times the half, of course, cancels. I'm going to add the 3 over. And then, of course, I'm going to divide by 39. So it doesn't matter to me. Personally, I didn't want to deal with the fraction anymore. That's why I times by 2. You are welcome to distribute it. Whatever you want to do.
I literally just did the same thing, but I just said that was 57 times 2.
That's how I would do it. All right, so again, inscribed angle. Now, here's the tricky part about this one. Every one of these are different. There's a few of these at the end of the homework, of course. We can't do all easy problems. So I don't know the intercepted arc. So here we had on the previous problem, angle arc. I need the arc. So get ready. I'm going to get creative here. If you know the angle, you double it to get the arc. So I'm going to double this. I'm going to double 26, and I'm going to double the 1. So there's my expression for the arc. Now, I don't expect you to write this. I'm just going to put it above it. How I got that, I did 2 times 26x plus 1. I doubled the angle. Now you might be like, well, what's the point of that? What's that going to do for me? Well, we still haven't solved for x, have we? But I take a look at these. You have the entire circle, the whole circle. We know that an entire circle totals 360. So I'm going to take all my arcs, 52x plus 2, 51x plus 3, and then the third piece of the puzzle, 74x and 1. Ay, ay, ay. And it should all add the full circle, 360. All right, now we just got to solve this piece. So we're going to add up our like terms. So I'm going to give you a minute to total all that good stuff up. And solve for x. You're going to get a nice whole number that's nice and small. I'm going to give you a minute to do it. Definitely need your calculator for this one. All right, final answer. X equals, anybody? Jacob, I couldn't hear you. 3. Anybody else?
I have
2. Should have 2. I'm guessing you just have an addition error in there somewhere. All right, final problem. And again, these are just a free-for-all, a little bit of everything. So right away what jumps out to me on this problem is like, oh, we have diameters, segments that go through the center, half circles. So I'm looking at where my variables are, and I'm like, okay, these make a half circle. Because here's a diameter. So I'm going to focus on that diameter. So half a circle, we all know by now, we've said it a million times today, totals up to 180. So I'm going to add up my 2 pieces of the half to 180. I'm going to do 18x plus 12x minus 2 the 180. All right, let's solve it. 18x, 12x, let's combine that. Let's add 2 to the right-hand side. And then, of course, I'm going to divide by 30. Final answer is, I feel like I forgot a 2, didn't I, Coleman? I'm like, I forgot part of the 18x. I forgot it had a plus 2 with it. My bad, sorry guys. So the plus 2 and minus 2 cancel out. I'm going to rewrite this. I made it a mess. Let's rewrite it. 30x equals 180. We're down 2. We'll get 6. There we go. So most of the homework, pretty straightforward like the beginning. The arc is this, find the angle. The angle's that, find the arc. Bing, bang, boom, it won't take you very long. Then towards the end of the homework, there's some of these kind of free-for-all problems where you have to go through, of course, I'm going to give you the homework here in a minute, find the very